Hello everyone. Today in this session we are going to discuss about digital transmission. Digital transmission, we can represent the digital data by using digital signals, and the conversion involves three techniques, that is line coding, block coding, scrambling. Line coding is always needed. Block coding and scrambling may or may not be needed. Next heading is line coding. Line coding is the process of converting digital data to digital signal. We assume that the data in the form of the text, numbers, graphicals, images, audio or video are stored in the computer memory as a sequence of bits. Line coding converts a sequence of bits to the digital signal. At the center, the digital data are encoded into digital signal. At the receiver, the digital data are recreated by decoding the digital signal. We can formulate the relationship between the data rate and signal rate as S is equals to C into N into 1 by R baud, where N is the data rate, that is bits per second, C is the case factor which varies for each case. S is the number of signal elements and R is the previously defined factor. Example, a signal is carrying a data in which one data element is encoded has one signal element, R is equals to 1. If the bit rate is 100 kbps, what is the average value of the baud rate if C is between 0 and 1? Then, by using this formula, the answer we'll get is 50 kbaud. Line coding scheme. We can roughly divide line coding scheme into 5 broad categories as you see in the diagram. In this diagram, those are classified into 5 categories. One is unipolar, polar, bipolar, multi-level, multi-transition. We'll discuss in detail one by one. Unipolar scheme. In the unipolar scheme, all signal levels are on one side of the time axis and either above or below the NRZ, non-zero, non-return to zero. Traditionally, a unipolar scheme was designed as an NRZ scheme in which the positive voltage defines bit 1, zero voltage defines bit 0. It is called NRZ because the signal does not return to 0 at the middle of the bit. Next one, polar schemes. In polar schemes, the voltages are on both the side of the time axis. For example, voltage level for 0 can be positive and voltage level for 1 can be negative. Next one, NRZ. In polar NRZ encoding, we can use two levels of voltage amplitude. We can have two versions of polar NRZ and NRZ land 1. Next, RZ return to 0. The main problem of the NRZ encoding occurs when the sender and receiver clocks are not synchronized. The receiver does not know when one bit has ended and the next bit is starting. One solution is to return to 0 scheme, which uses three values positive, negative, and 0. In RZ, the signal changes not between bits but during the bits. Next heading is block coding. We need redundancy to ensure synchronization and provide some kind of inherent error detecting. Block coding can give us this redundancy and improve the performance of line coding. In general, block coding changes a block of m bits into blocks of n bits where n is larger than m. Block coding is referred to as an MB or NB encoding techniques. Transmission modes. We need redundancy to ensure synchronization to provide some kind of inherent error detecting. Block coding can give us this redundancy and improve the performance of line coding. In general, block coding changes a block of m bits into a block of n bits where n is larger than m. Block coding is referred to as an MB or NB encoding technique. In the transmission mode, the of primary concern when we are considering the transmission of data from one device to the another device is wiring. And a primary concern when we are considering the wiring is data stream. Do we send one bit at a time and do we group bits in large groups, and if so, how? The transmission of the binary data across a link can be accomplished either parallel or in the serial mode. In parallel mode, multiple bits are sent with each clock tick. In the serial mode, one bit is sent by with each clock tick. While there is only one way to send parallel data, there are three subclasses of serial transmission, that is asynchronous, synchronous and isochronous. Digital transmission, as you see in the diagram, it is classified as two types. One is parallel and serial. In the serial we have asynchronous, synchronous and isochronous. Parallel transmission. First we'll see parallel transmission. Binary data consisting of zeros and ones may be organized into groups of n bits each. Computers produce and consume data in groups of bits much as we conceive of and use spoken language in the form of words rather than letters. By grouping, we can send data and bits at a time instead of one. This is called parallel transmission. The advantages of the parallel transmission are the advantages of the parallel transmission is speed. All else being equal, parallel transmission can increase the transfer speed by a factor of n over serial transmission. It has also disadvantage that parallel transmission requires n communication lines just to transmit the data stream. Because this is expensive and parallel transmission is usually limited to shorter distance. Next one, serial transmission. In serial transmission, one bit follows another, so we need only one communication channel rather than n to transmit the data between two communication devices. As you see in the diagram, we have a sender and the receiver, that is a converter, serial and parallel converter, and we have only one communication channel. In this, the data is sending serially. The advantage of the serial over parallel transmission is that with only one communication channel, serial transmission reduces the cost of the transmission over parallel by roughly a factor of n. Since communication within the devices is parallel conversion devices are required to interface between the sender and the line parallel to serial and between the line and the receiver, that is serial to parallel. Serial transmission occurs in one of the three ways, that is asynchronous, synchronous and isochronous. In asynchronous transmission, we send one start bit 0 at the beginning, 1 or more stop bits at the end of the each byte. There may be a gap between the each byte. But in the synchronous transmission, we send bits one after another without start or stop bits or the gap. It is responsibility of the receiver to group the bits. But in the isochronous, that guarantees the data arrive at the fixed rate. In real-time audio and video, in which uneven delays between frames are not acceptable. Synchronous transmission phase, for example, TV image are broadcast at the rate of 30 images per second. They must be viewed at the same rate. If each image is sent by using one or more frames, there should be no delay between the frames. This is about this session. In this session, we discussed about digital transmission. What is a digital transmission? How the data is represented by using digital signals, and the techniques used for the conversion. Line coding, block coding, scrambling. Line coding, what is the line coding? It is the process of converting digital data to digital signal. And line coding schemes, what is a unipolar scheme, polar scheme, block coding, transmission modes. And we have two modes, one is parallel mode and serial mode. And again in the serial mode, that is going to classified as asynchronous, synchronous and isochronous mode. And what is the parallel transmission? What is this serial transmission? And what is the types, what are the types of the serial transmission? This is about this session. Thank you.